today. Give me questions about your homework. I'm sorry, I didn't hear you. 21, thank you. Uh-huh. Okay, let's see. We got x squared minus 4, and I would definitely use my calculator for this one. Yes, to graph it and to find the, let me show you how I would use my calculator here. 16 through 18 are non-calculator, but then we get to 19 on in their calculator, so this is definitely what I would do. I probably should have showed you this yesterday, and it wasn't helpful. All right, I'm just going to graph both of them. Absolute value of, I have x squared minus 4, and then x squared over 4 over 2 plus 4. There we go. Let's see what I'm looking like. There's the first one. Here's the second one, right? I'm going to adjust my window just a bit so I can see, because what I really need to know is where they're intersecting up here, right? And I can't quite see that. So I'm going to take my window, I'm going to adjust my Y. I don't need to see below that x-axis because nothing goes below it. I might take this up to 20, and let's just see what happens. Now I can see, right? So I'm going to do the integral. You can double it, but since I'm using my calculator, I'm probably just going to go from here to here. I'm probably not going to use symmetry, but if you want to, you can. I'm going to calculate the intersection of the two. Nope, not there. Four. And I'm going to assume this is symmetrical, and this is -4. So I'm going to do my integral. No. I'm going to do my integral this way. And I'm going to do, which one's on top? Y2? You sure? Minus Y1 with respect to x, not 0, from -4. So what you got or no? Are you saying, oh, because it was so much easier? Hopefully, if I went from, let's see if I did the same thing, but I went from 0 to 4. And then times 2. Did you do it by hand? How did y'all integrate the absolute value of x squared minus 4? Yeah. I couldn't figure out how to do that one either. You just turned it into parentheses. If you did it, it would have, do y'all care? From here to here, it's negative, it's the flip of it, so it's negative x squared plus 4. But on these ends, So you'd have to set up 1, 2, 3 different. You'd have to set up 3 different equations. You'd have this equation from negative infinity to negative 4, which is just x squared minus 4. Then you'd have a reflection and shift it up there, right? So you'd have negative x squared plus 4 from negative 4 to 4. And then you'd have, is it 4 or is it 2? 4. And then you'd have the regular equation here. So from here to here, you could just drop the absolute value signs. But here, you would have to negate it so it flips, if that makes sense. So you'd have to do 3 different ones to do the absolute value. It'd be really difficult. That makes sense. Definitely a calculator problem there. What else on your homework? 24. Another calculator looks like. Let's see. But they're not solved for anything, right? And then 4x minus y equals 16. I guess we'll start by solving them for y and seeing what happens. Great day. My eyes are just. Thanks, Henry. I looked at the problem right above it. X plus 2y equals 3. Yeah, I know. This actually might be easier to solve for x, then I'm going to assume they want us to take the integral with respect to y on this one. Is that what this looks like? But I still need to solve it for y so that I can graph it, yes? Yeah, then you did it with respect to x. Yeah, if you're using your calculator, it would work. Should have got the same answer. Did you get 4? Yeah. Because it doesn't matter. All you're doing, you're twisting everything up, but that's okay. No, but it does. It works. It's fine because it is another variable. So what Avery's saying she did, yeah. Sorry. And then just changed it to y equals x squared and y equals 3 minus 2x, and then did her integral with respect to x, which would work also. Either way, and plugging in the calculator. That might be a little bit easier to see so you don't have to worry about the positive or the negative roots there, and you can just worry about, well, because you're, I mean, using, if I do it this way, if I solve it for x here, and then I just put it in my calculator as, remember, it's just a variable at the end of the day, right? So I could say y equals x squared, but whenever I integrate, I'm going to integrate with respect to x instead of with respect to y. It's essentially just taking it and going boop, and then instead of integrating this way or this, I switch the way I integrate if I switch the way the graph goes. Does that make sense? They're inverses. No, that's not making sense to you. Okay, so inverses switch x and y, right? And that by definition the inverse. So instead of taking the integral with respect to y and doing right minus left, I'll just switch x and y and take it and do top minus bottom. So that's a little easier. So now, especially since it's a calculator problem, if this was by hand, it might be easier if I had the graph that I could just do, okay, square root of x, and then I got this other one, and then I could do whatever they come out to be. All right, but we'll do it Avery's way. All right, what did I say? X squared and the other one was 3 minus 2x squared. Now I can do it with respect to x, right? I just need these intersection points. That's the whole point in graphing it. I need to know where they cross. And since I'm doing it with respect to x, I need those x values. These are symmetric. These haven't been shifted left or right any, so they're symmetric about y. So whatever this intersection point is here, it's going to be reflected over here. So I really only need to calculate it once. Let's see. Intersect. 1, 1. So I'm going to go from -1 to 1. And I'm going to do which one's on top, the one that's upside down. So I'm going to do y2 minus y1. We'll do y2 minus y1 with respect to x from -1 to 1. Or from 0 to 1 doubled. I get that. Isn't it amazing how much a calculator can do? Isn't that cool, y'all? No, y'all are not impressed. Thank you. Didn't he what? No, if you had done it this way and you could have solved for y and done it this way, then you would have had to integrate with respect to, what do we solve? You essentially did the same thing there. But you could have graphed this and graphed this, and you should get the same thing. Well, since you solved it for y, no. If you solved it for x and then you graphed, then you would do, because this would be the integral. It was -1, 1. Is that right? This would be the integral of, you would do 3 minus 2y squared minus y squared dy. And it would be the same thing. I feel like respect to y confuses more than it helps sometimes. Unless you're given, so if you solve, this is easier to solve for x than to solve for y, right? So if I solve this for x, this is what Avery was saying she did. She solved it for x because it was easier to solve for x, but then she just switched x and y when she put it in her calculator. So that's where the y squared came from. Right. Let me just make sure before I tell you this. Let me show you what this looks like if I solve it for y. These are both of them solved for y, right? And I graph them. So if I were to do this with respect to y, it might be a little bit more difficult for me. So I've got this picture that looks like this. This equation is the square root of x. This equation is, and the only reason I had to solve it was to put it in my calculator, or to solve it for y, is to put it in my calculator. 3 minus x over 2. What I would need to do just to do this with respect to y, the way this is graphed, because I don't have a top curve and a bottom curve here, right? So the way it is now, what I'd have to do is I would need to come back. I'm still going to need it solved for x, right? And so I would do y squared and 3 minus 2y squared. So this one is x equals y squared. This one is x equals, what did I say? 3 minus. So now with respect to y, I would go from, I need this point. It makes it a little bit harder to use my calculator now. 1. I'm going to go from 0 to 1, and I'm going to do right minus left. So and I'd be in a situation of kind of doing it by hand here. Unless I wanted to put this equation in my calculator to find the derivative of. That makes sense? Tough crowd this morning. Yeah. Either way, you should still get 4. I'm kind of scared to do it, to be honest. You got what? Do it this way? No, stop. Um, 0 to 1. Why is it giving us 2 with respect to y? That's what you got last night when you did it too? I know why. It's exactly what I said in the very beginning, and then I still didn't go back and do it. Right? Which means it's got a bottom part too. We just found this, but there's actually all of this also. So we have to double it. That's exactly why. That's the problem with taking square roots, right? You got to take the positive and the negative. There's Stacy. I knew there was a simple explanation. What else on your homework? 33. Bruh. This is when y is between negative pi over 4 . No, this one's negative. I'm going to use the same mentality that we did with the last one. What happens when you graph it? Did y'all graph it? Y'all calm down. My gosh. Do a zoom trig. But I want my x to go between negative pi over 4 and pi over 4. And what does it want? It wants the area. What it looks like. So I got tan squared, negative tan squared. And then I set my window. This is negative pi over 4, pi over 4. And I just kind of zoomed in some here so you can see. I think I times that by 4. 1, 2, 3, 4. I just did the integral from 0 to pi over 4. Yeah. Second calculate. 7. Lower limit. Or even if you want to do, and just double it, do negative pi over 4. Trace. Second trace. And then go to pi over 4. Second trace 7. Double that. Yeah. If it's a calculator problem, for sure, just take it out at least 3 places. Or you could come out and do like we did before, and you could do which one's on top? The positive one's on top. It's going to be y1 minus y2. No. I requested 1. I need to just go by 1. Or I can just run it top minus bottom. From negative pi over 4 to 4. Either one of those will work. Looking at y'all's faces, it almost hurts my heart to know what I'm fixing to show you today. We have 2 more things to learn. That's it. Just 2 more. Today's one. Don't wait another day. Okay. Do y'all have any other questions about your homework? Yes. Y'all take a break for just this second. In hand with the revolution. So really, it's only one more lesson. It's just that it's yeah. You saw something about what? Yeah, it is pretty. Here's what we're gonna do. We're gonna take this solid shape, okay, that follows a curve of some sort, and let's just take Something basic to start with. This is x squared, right? This just in this quadrant. If I said, let's say this is, if I said that there was this solid shape, that the base of it sat right there following along this curve, this is the base, and that I could take cross sections out, I could actually cut this whole shape. I wish I had a visual. I could actually cut this whole shape into slivers. Remember how we did RAM and it was little rectangles? If this one I could cut, think like a loaf of bread, and I can cut pieces out, right? The only difference is I'm going to tell you what shape these sections are going to be that I'm cutting out. So maybe they're squares, maybe they're triangles, maybe they're semicircles, maybe they're full-on circles. Whatever it is, there's a shape. And what we're going to do is we're going to use integration to find the volume of this solid, okay? So here's what we have to do. Here's what you have to remember, that volume is the integral of area. This is the area of one cross section. And then, of course, I have my bounds. Not well, how do I get it to go away? Okay. Oh my gosh. All right. Yes. All right. So first, I want you to be able to visualize the cross sections. That's what I was over here looking to see if I could find a good visualization. So here's a good visualization. This first one on the bottom left, if I did semicircular cross sections, see how each little piece is a cross section? So essentially what it's doing is, remember, integrals is just an infinite number of these rectangles or whatever shape I'm using. So in this case, it's going to be semicircles, and it's an infinite number of them, and then it adds them all together. So this would be what the shape looked like. If I let it be rectangles, here's my rectangle. I don't think this has, yeah, there's a triangle. Triangle. Rectangle. Do you see what I'm, does it make sense what I'm saying a little bit? And you see the cross, okay. This is the hardest part, is coming up with the area of the cross section. Okay, so we have to think about things like, how do you find the area of an equilateral triangle? How do you find the area of a circle? How do you find the area of a square? Things like that, because that's where it's going to come in. Okay, so if, let's say, for instance, I've got my, what's wrong? Is it not making sense? Oh, I'm sorry. I didn't even notice. See, I didn't even notice. That's just Khalil. Let's say I've got y equals x squared. Not even talking about volume right now, but let's say I want to pull out cross sections that are, let's just say square cross sections. What is the area of just one square cross section? Anywhere you want to go, I want a general formula. If this is my cross section, I don't even know how to do this three-dimensionally. There's a square. I don't know. I don't even know. I can't draw it. But this square, understand, right? It's sitting like this. It's coming out, okay? So how could I find the area of that one square? Just the one right now, just one. How do you find area of a square, first of all? Right? But it's a square, so the length and the width are the same. So just the side squared, right? That's the area, right? Everybody in agreement? Now for this particular square, what's the area? Okay, what point is that? General. I want general. It's y. What is y? x squared. General, right? The area of one cross section is x squared squared. Because if this square is coming out, so no matter where I go, if I went to, let's say I went to 1.5, well, the square that sits at 1.5, the area of that square would be 1.5. This point is 1.5 squared, right? So this height is 1.5 squared. So the side is 1.5 squared, which means the area would be 1.5 squared squared, right? 1.5 squared times 1.5 squared. Does that make sense? No? Okay, so it's double. Right. Let's make it a. I got squares coming out of y equals x now. What's this length? Right? Because that length is the height from 0. So this point is x, x. So if this was a square whose base was x, it means its side is also x. So this is the base. These are the same lines, but it's coming up. So the area here would be x squared. But up here, this point is x squared, right? So the base of this square is x squared. You agree? No. Which means the height is also x squared. So if I want the area of this, I would have to multiply them together. Whatever that equation is going to be your width there. So. What do these two things look like? Okay. On a graph, what does this look like? Okay, it's supposed to be a circle. If I solved x squared plus y squared equals 1, right, subtract x squared and take the square root, the positive and the negative value, I'd have this circle with a radius of 1. This way you can see what y equals everywhere. This one is the square root of 1 minus x squared. This one is negative square root of 1 minus x squared. Okay, here's my function. If the cross sections here are circular disc, okay, so think about this like a ball, okay? This is a ball, and I'm going to slice it up. I used to have a little thing that would put, okay. And you pull out slices. What is the area of one of those slices that you pull out? Okay, so I know, first thing I need to do is say, okay, they're asking me for area of a circle. That's essentially what they're doing, right? If I pull out a circular disc and this is a ball, even though mine looks like a squished oval, it's not, it's a circle. Okay, and I pull out a circle out of, right? I'm looking for the area of a circle, and we know that's pi r squared. So my question now is, all I need to know is anywhere on here, what is the radius of the circular cross section that I would pull out? One at zero, but I need a general. What if I'm over here and here's my circle that's coming out, right? Radius is half. So really, I'm only looking for the distance from here to here. Do you agree with that? That would be the radius of my circle. You're right. That's right. Yes. So the radius of this circle would be square root 1 minus x squared, but I square it for the area of the circle. Yep, so I'd have pi times 1 minus x squared. That's the area of the circle. Just to show you how I get the equation of that circle. But since it's radius, I only need half of it. Change it up. Yes. Yes. Because it's distance, I was looking for distance and area. So at the end of the day, even though this is a negative equation, this distance is going to be this. It's still square root of 1 minus x squared. But right now, I'm working through number 1 from your homework, by the way. This is number 1, and they set it up, and this is the way it starts. They give you a nice little picture, though. It's a lot better than my picture. I'll show you. 419. It's a bit confusing to me, but it's a nice picture. You can at least see these circular pieces that are coming out. So part B says, switch it up. They're not circles anymore. Now they're squares. So cross sections are squares. What's the area of just one cross section? Mm-hmm. What's the base? Because I need the base of the square. Not square because you're not multiplying them. 2 of them, right? Now, yeah, that's part B. A is circles. I told y'all to buckle up. Okay, now we're doing squares. So now, sitting here, I don't know. Okay, so there's this square that just magically comes out. What's the area of the square? Okay, side length. Let's do side length first. The side, go ahead. 2, that's right. 2 of these, right? And because I'm talking about a side length, I don't want to incorporate a negative in there because the side of a square is never going to be negative. So I'm just going to say that it's 2 of these. It's 2 square root of 1 minus x squared. I don't want to multiply them together because I'm adding them. It's 2 of those put together. Does that make sense? Yes. Does that make sense? So the area of this, it'd be that square, which would be 4 times 1 minus x. Or y'all okay with the easy shapes so far? I don't know that we ever do trapezoids with them, but we do other like equilateral triangles, and I'll show you in just a minute. What was your question, Caroline? You asked me something. Somebody asked me something. No? Somebody? Say again? We're just doing equations right now. You're walking out, done. Right now, yes, but we're fixing to. That's the hard part. That's why we're spending so much time finding, because remember, volume is, if I wanted to do the volume of this, it would just be from -1 to 1 of this equation, dx. So the hard part is nailing down that equation. Yeah, because the integrate area gives us volume. That's why. Bye, Henry. Have fun. We'll have even more fun while you're gone there. Caroline, you're not gonna tell her bye. I heard her. She said bye. She loves you, and be careful. Yeah, she did. The cross sections. Y'all ready for part C? There's a C and a D. We're ready. We're ready. Okay. The cross sections, get ready for this, are squares whose diagonals sit on the XY plane. So now, that's exactly right. I don't have a side length. I have a diagonal length now. I have this length. This length is now 2 times the square root of 1 minus x squared, right? So it says the cross sections are squares with diagonals in the xy plane. Essentially a triangle and doubling it, you could think about it like that. Or I could think about it being a square and I need, here's where you got to go back to geometry a little bit. This is 90 degrees, right? A diagonal splits it. Wait till we do the triangle. If you have a 45, 45, 90 triangle, these sides are the same, right? Say right, because that's right. And then whatever this is, I multiply it by the square root of 2 to get the hypotenuse. That's that special triangle. So if I need to go backwards, well, but that's not under a square root. So it's going to be which I could clean up a little bit if I wanted to. 2 root 2. And I can put these both under that. The radical here, because they're being multiplied and they're both in a radical. That's that little radical property. This is the same thing. Because if I go from a leg to hypotenuse, I multiply by square root of 2. But here I've got the hypotenuse, so I need to go backwards. So I need to divide by square root of 2. I multiplied by the square root of 2. This is one side. Remember, I was trying to find the area of the square. That's one side. That's right. Yes, that's correct. Side to side. Y'all ready for the last one? Oh. Let me give you a hint before I do it. Y'all remember this triangle? I feel like we've done this in here. Always have to make your way back to the short leg. 30, 60, 90. The short leg's across from the 30 degree. Y'all remember this? Or no? Okay. So wherever I am, I have to make my way back here, maybe by dividing, and then I can find the rest of the legs. So let's say that my cross sections are equilateral triangles whose base sits in the xy plane. So now I'm equilateral triangles. This is part D, by the way. Equilateral. All sides are the same. Well, I'm glad you asked. How do you find the area of an equilateral triangle? How do you find the area of a triangle? 1/2 base times height. I know the base, or I should know the base. The base sits on the plane, right? The base is the same thing I've been working with this whole time. It's 2 of these, or this whole length, right? So it's 2 times, what was it? The square root of 1 minus x squared. That's the base. The height is what I need. The height is going to be a little bit of trouble for me. I've got this equilateral triangle. My height drops down. How in the world am I going to find that? What are the degrees of the angles in an equilateral triangle? Is it 60? Yes, it's 2, 30, 60, 90 triangles. So this is 60. This would be 30, right? I need the 60-degree side. What do I have? Well, I have all of this. So all of that is 2 times the square root of 1 minus x squared. You're exactly right. I got to divide it by 2. So here's what I really have. I have, this is 1 minus x squared, the square root. How do I find this side? Because that's the height. You have to multiply it by the square root of 3. That's exactly right. Because this is my short leg. Short leg to long leg is times the square root of 3. So this side is going to be square root of 3 times the square root of 1 minus x squared. That's the height. Now I can plug that in here. Now I have everything I need to find the area of the triangle. But not Yes, two. Yes, two. You're right. You're right, two. So my area of my equilateral triangle would be 1/2, and then the base is 2 root 1 minus x squared. And the height is square root of 3 times 1 minus x squared. I'm not going to clean that up anymore right now because I'm not asked to do any more with it. If I'm asked to find volume, I'm probably going to combine it and clean it up a little bit because I'm going to have to integrate and do all that good stuff. But for right now, I'm leaving it just like that. The only thing I want you to do tonight is number 2. It's exactly like number 1 we just worked, but it's a different equation. And you're doing areas of the cross sections. We're not even doing volume yet. I just want you to be able to identify the cross section and find the area of just the cross section based on the equation that's given. The volume's really easy though. If you do the volume, it's literally you take this equation and you run it from whatever it tells you to run it from. This is the hardest part. And then